All right, guys, are there any questions on any of the assignments before we get started? Question on the homework before we start? So, first thing we're looking at is the square root of a negative number property. Now, this is pretty straightforward. I would have one of each. Well, actually, for this here, we really don't need the graphing calculator because we needed it for I, but for the most part, we can. Thirty XS.
30SX. You want
30 XS. So, the square root of a negative number property. So if r is a real number, then the square root of negative r is I times the square root of r. We did this in 341, taking the square roots or simplifying those square roots. By the first property, it follows that if we square what we got, it'll get back to negative r. This is kind of straightforward. If we took the square root of negative r, we get I times whatever the square root of r is. Then if we square that, we get back to negative r. Now, the first few things we're going to do is solve these quadratic equations that we weren't able to solve before. Now, this first one here, we can solve by the square root method. We know we can solve by the square root method because there is no middle term. We just have our x squared. And the first step in the square root method is to get the square term by itself. So we would subtract 4 from both sides, telling us that x squared is equal to negative 4. Now at this point here, we do have the x squared term by itself, so we can square root both sides. And the square root of x squared would be x is equal to plus or minus, because whenever we take the square root of both sides, we do have to add the plus or minus. It's just, when I copied it, I made sure to kind of increase the contrast so that it made sure to copy well. All right. You're welcome. Now, we need to take the square root of negative 4. Now, the first time we went over square root method, we did not have a way to take the square root of a negative number, but we do now, because the negative will come out as I, and the square root of 4 is 2. So the graphing calculator does need to be set in A plus BI mode. So we'd have to go to mode, down to real, and over to A plus BI, hit enter.
A plus BI. I got it.
Mode. Go. Mm-hmm.
Second quit now?
Oh, yeah.
Yeah, second quit or clear.
Clear.
Because you need to do A plus BI. And then down to where it says A plus BI, hit enter.
Oh, I see it.
So you go down, select it, hit enter, then you can hit clear, and it'll take.
You gotta guess. You gotta guess.
Yeah. Oh.
What is it? This is like restarted. I don't know what you did, dude.
So the original equation was x squared plus 4 equals 0. We found the value of x is 2i. So if we plug that back in, 2i squared plus 4 is 0. Negative 2i squared plus 4 is also
There's also 7.
0.
Wait, how do you reset this? 7 plus 7. Wait.
Second plus
Second plus 7 is 6.
7, 1, 2.
7 plus 7.
Questions on this here?
It's your fault. I'm sorry.
Let's look at the second one. Say 2x squared minus 11 equals negative 47. And again, there is no middle term. We do have just the term being squared. So we need to get it by itself. We would add 11 first, which will tell us 2x squared is equal to negative 36. And then we would, almost, is the x squared by itself. Then we divide by 2, telling us that x squared is equal to negative 18. Now we would take the square root because, guys, the x squared is by itself. So we would take the square root of both sides. Square root of x squared is x equals plus or minus. Now we do need to take the square root of negative 18. Now, the graphing calculator gives us a decimal because the square root of 18 is not a perfect square. The yellow calculator, the 30XS, will not take the square root of negative 18. It does not like negatives.
It won't go fraction either.
Now, what we can do is we can pull the negative out, leaving us with just the square root of 18. And if we take the square root of 18, we get 3 square root of 2. But we didn't plug in, I didn't plug in the square root of negative 18. I plugged in the square root of 18.
That's what I did. What? Well, that cat cracks me up.
So to simplify non-perfect square radicals, we first take the negative out as I, and then plug what we have left into it.
So that square root of 2 will always go after the I.
We normally put radicals after I. Questions on this here? Let's look at one more. Find the zeros of f of x equals 4x squared plus 20. Well, when we find the zeros, we're trying to find out what value of x will make 4x squared plus 20 be 0. So we're looking at 4x squared plus 20 equals 0. In the first step in solving this, minus 20 from both sides, we're going to use the square root method, which will tell us that 4x squared negative 20. Our next step would be to divide both sides by 4, telling us x squared is equal to negative 5. And then we would
Square root
square both sides,
x squared by
plus or minus. Well, the negative is going to come out as, we need to take the square root of 5.
it's 5.
Square root of 5 is square root of 5. It doesn't reduce. So we just leave it as the square root of 5. I mean, we technically did this last Friday, but the I part didn't come into play.
I don't believe that.
I have an iron deficiency.
Where did that come from?
Because iron regulates your body.
Maybe you should.
All right. We're going to look at this first example. Now, we're going to do this a little differently than normal. We are going to use the square root method. But the first thing we're going to do is not get it equal to 0. What I want to do first is factor the quadratic. I want to factor the x squared minus 16x plus 64. Now, there is not a greatest common factor between these three terms. So we'll go to our two sets of parentheses with 3 spaces. If the third term is positive, the signs are the same and match this side of the middle term. If the third term is negative, the signs are opposite. So here, the third term is positive, so the signs are the same, match the sign of the middle term, so they would both be negative. Now the factors of the first and third term. Factors of the first term would be x and x. Factors of 64, 1 and 64, yes. 2 and 32, 3 doesn't work, but we do have 4 and 16. And then we have 8 and 8. A week. 8 and 8, if we do check this here, we would get negative 8x minus 8x is negative 16x. That is the middle term we want, yes? But there is something interesting about our two factors. They are what? Because one of them is x minus 8, the other is x minus 8. These two factors are the same. Another way we can write something being multiplied by itself is I could reduce this to what? X minus 8 squared. X squared minus 16x plus 64. We actually call this a perfect square trinomial. It is a quadratic that can be written as a single set of parentheses squared. And because it is a single set of parentheses being squared, I can actually take square both sides. I can apply the square root property to it. Because our square root and square will cancel. Because we can type it in either one. Because the square and square would cancel, leaving us with x minus 8. Square root of 100?
No, the whole. No, we can't.
10. So x minus 8 is equal to 10. At this point here, we can solve for the value of x. Add 8 to both sides. Telling us x is equal to 8 plus or minus 10. Now, before we say we're completely done, can we add 8 and 10? Can we do 8 plus 10? Can we do 8 minus 10? So we have to finish this. We do have to simplify it because x is equal to 8 plus 10. What is 8 plus 10? So one of the solutions is x is equal to 18. We do also have x is equal to 8 minus 10, which is plus negative 2. Because the plus or minus means that we have 8 plus 10 and we have 8 minus 10. We have two different setups. And if we are able to add or subtract them, we need to add or subtract. Now the exception would be, use this color. So if we had 8 plus or minus 10i, are 8 and 10i like terms? No, so we can't add or subtract, so we would just leave it as 8 plus or minus 10i. But because it's not 10i, it's just 10, we will add and subtract and get 18 and negative 2. Questions on this here?
Why didn't you just plus 8 and add it to the other 10? Or to the 10 on this side?
Because this 10 is not just 10. It is positive 10 and negative 10. It is both of them at the same time. So instead of splitting up when they took the square root as x minus 8 equals 10, x minus 8 equals negative 10, writing it as two separate statements, the plus or minus lets us write it as one statement. Any other questions on this here? Questions on anything we've done so far? We feel good with this here. Now, one of the things that was critical or crucial for this to work was that this quadratic here was a perfect square trinomial, that we could rewrite it as a single set of parentheses squared. Because if it wasn't, none of the rest of this would work. And that's really the crucial step here, because if I can make this quadratic, this side of the equation, be a perfect square trinomial, then we could do this every time. And that really leads us into our first method that works every single time, which is completing the square. Now this slide's not on your note sheet, but completing the square is the first method that works every single time. And the key to it is getting a perfect square trinomial, a quadratic that we can write as a single set of parentheses squared. Now to do that, our first one here, is being able to take any quadratic and turn it into a perfect square trinomial. And to do that, we need to find the right value of c, the constant term. And our constant term that we need for it to be a perfect square trinomial is given to us by this equation here. C is equal to b over 2 squared. C is equal to b over 2 squared. And this is all going based off our standard quadratic equation. Ax squared plus bx plus c. Now for the equation they gave us here, x squared plus 14x plus c, what is the value of b? 14. Positive 14, so we plug in positive 14. Now when completing the square or finding these perfect square trinomials, we could plug in parentheses 14 divided by 2, close parentheses squared, and let it do it for us. I would highly suggest doing the division of 2 first and then squaring it. Because 14 divided by 2 is, 7 squared is. So for us here, to make this a perfect square trinomial, our value of c would be 49. So this perfect square trinomial is x squared plus 14x plus 49. We have now made it into a perfect square trinomial. So that's half of the problem here. Now it does say to write the expression as the square of a binomial. Binomial is two-termed, or just a set of parentheses squared. Now for all these here, when we rewrite it as a set of parentheses squared, we will have x, and then we will have a sign and a number. Now the sign and the number will always be whatever we have inside the parentheses before we square it. So the number we have inside the parentheses this time before we square it was 7. Was it positive or negative? So it's going to be plus 7. If it had been negative 7 before we squared it, it would have been x minus 7. That's it. Because at this point, we're working on creating perfect square trinomials. Get ready for the next one. I'm realizing more and more I need to fix these slides because they're slightly pixelated. You all agree with that?
Oh, yeah.
All of that's
As long as
controls it. Yeah. All I've got to do is go back in and then just retake the picture and make it a little better. Now, the first one we're going to look at is number 4. Put it back to this here so I have a little more room. Now, the first thing we need to do to find the perfect square trinomial is to find the value of b and plug it in. So for 8, it is 8. Now again, we could plug that in and get straight to the value of c, but the number inside the parentheses before we square it does help us with the factor. And doing 8 divided by 2, 4, and then squaring it, for the most part, isn't too bad. So that tells us the perfect square trinomial for this is 8x squared plus 8x plus 16. Set of parentheses squared. We will have x. I mean, if it was y squared plus 8y plus 16, then it would be y first. And the number that goes inside the parentheses is the number. It would be plus 4. Number and sign before we square it. Yes. Let's look at the next one. Number 5. X squared minus 2x plus c. So our c is equal to b over 2 squared. So b in this case would indeed be negative 2, because we take the number and sign, so negative 2. Now negative 2 divided by 2 is, and negative 1 squared is 1. Now it will work out that the value of c that we replace c with will always be positive. Because whenever we square a number, multiply a number by itself, it will always be positive. The only way it will not be is if the number we're squaring is I, because I squared is negative 1. Inside the parentheses, we will have x, and the number we're going to put in with it is minus 1, because the number that we had before we squared it was negative 1, so we get x minus 1. Questions on this here? Let's look at the next one. For the last one here, the value b would indeed be negative 9. So we plug it in to our formula and get the quantity, negative 9 over 2, close parentheses, squared. Does 9 divide by 2 evenly? We would have a decimal, yes? In any of these cases here, leave it as fraction. It's going to be easier to work with these and easier to solve these especially when we start completing the square, if we leave them as fractions. Normally we like decimals better, but fractional form is going to be easier to work with. So since it doesn't reduce, we'll leave it as this here. And we can always plug it into the calculator, -9 over 2. I would use the fraction key and see what fraction do we get. Here we just get -9/2. So we can leave it as that. Now we can square it, and we could do that in the calculator, and it would tell us that it's +81/4. So that tells us our perfect squared trinomial would be x squared minus 9x plus 81/4. A compressor for the sprinkler system or the fire suppression system. Because all this, well, for sprinkler systems to work properly, they have to stay under pressure. So it's making sure that the sprinkler system's pressure stays at the correct level.
Oh, so if we have a fire,
It can push all the water out. And this here would be x minus 9/2. Yes, 9 over 2. And that's it. And this here is the key to solving by completing the square. This is the biggest part of the whole thing. Questions on any of this here? Now, I'm not going to make y'all write all these steps out today. We will go through this tomorrow. I want to do one more example with y'all. Then I will give you the assignment and you'll have the rest of the time to work on it. 2 of the problems on the homework are solving, but they give it to you in a form, like example 1 that we did first, where it's already a perfect square trinomial. You just need to factor its square root both sides and solve. When we start actually working with problems that deal with completing the square, we have 4 main steps. The first step is A equal to 1? If not, make it so. Once we finish that, we want to get the constant terms away from the variables. We want to get the constant terms, the terms without a variable on one side, everything else on the other. And leave 2 places. Third step is find the value of C, B over 2 squared, and plug it in. And then we want to find the perfect square trinomial and solve. So what we have is our x squared minus 10x plus 7 is equal to 0. Now we could graph this and it will cross the x-axis, but it does not cross at whole numbers. It's actually going to be at 2 irrational numbers. Now, I'm going to work through this. At this point, I would suggest just kind of watching and following along with what we do, because we will do these tomorrow. I just want to give you guys an example, or just so that you can see it for once before we start really digging into it tomorrow. And the first main step in completing the square is to get the number in front of x squared to be 1. Here, it's already 1, so we don't have to do anything. The next step is to get the constant term on one side and the numbers with our variables on the other, and leave 2 spaces. So we will put it so that the constant term, which is 7, is on one side, so we have minus 7. Our x squared and negative 10x are on the other. Our third step is really, third and fourth step, the next 2 steps, is to get x squared minus 10x to be a perfect square trinomial. And to do that, we'll find the value of C, which is our b over 2 squared. And in our case here, the value of b is 10, negative 10. Now our negative 10 divided by 2 would be negative 5. And negative 5 squared is 25. So we will add it back in, giving us x squared minus 10x plus 25. And if we rewrote this as a set of parentheses squared, we would have our x, and the number that goes in it would be our minus 5. So we got our x squared minus 10x plus 25, which is our perfect square trinomial, which does factor to x minus 5 squared. But if I add something to one side, I have to add it to the. That's why we do have the two spaces. Now our negative 7 plus 25 will be 18. And this is the nice piece about perfect square trinomials, because the equation we started with, x squared minus 10x plus 7, is not a perfect square trinomial. We made it into one. Now we have a set of parentheses squared equals 18. At this point here, we can take the square root of both sides, telling us x minus 5 is equal to plus or minus 3 square roots of 2. We already did the square root of 18 earlier today. But that leaves us with one last step. We do need to solve for the value of a, not a, x, and add 5 to both sides, telling us that x is equal to 5 plus or minus 3 square roots of 2. And that is the final answer. Because 5 and 3 square roots of 2 are not like terms. We can't add them or subtract them. So we leave it as this here. And this is the first way, the first method that will work every single time. Questions on these here? And that's it. Problems 3 and 5 are solving by radicals, but in both cases, 3, the quadratic on the, one too many, x squared minus 8x plus 16 is already a perfect square trinomial. You can do your normally factoring and get it down to a set of parentheses squared. And number 5, x squared minus 8x plus 81 is a perfect square trinomial already. We can get it to a set of parentheses squared. If you have problems with those, that's fine. Please ask. I can help you with those. But I am confident with 11 through 18. 11 through 18 is finding the value of c and plugging it back in, and then rewriting it as a single set of parentheses squared.